Hi everyone, this is your math guru. In this video, I'm going to give you a quick summary of all your grade 10 functions, starting from your linear function, your quadratic function, your exponential function, and your hyperbolic function. Please don't forget to click on the like and subscribe button below for more easy to understand math concepts. I'm going to start with the linear functions or your straight line. The standard equation for grade 10 of a linear function or a straight line is your y equals ax plus q. It can also be referred to as y equals your mx plus c in some textbooks. It means exactly the same thing. Your a, as it is your gradient, which is also your m in this case. And the gradient, the value of your a determines the steepness of the line. Your q on the other line, or your c in this case, is your y-intercept. If the value of your a or your m in either case is greater than 0, or if you have a positive value for your a, what that means is you're going to have a positive gradient. And likewise, if the value of your a or m is less than 0, you're going to have a negative gradient. Also, the bigger the value of a, the steeper the graph. The value of y, on the other end, determines whether your graph is moving upwards or downwards. So if I have a negative value, that is if the value of q or your c is greater than 0, what that means is my graph has moved or shifted q units upwards. And if the value of q is negative or less than 0, what that means is my graph has moved q units downwards. While drawing a graph, it's important to know what the value of the gradient is. You want to know what the intercept is, and you also want to know if the graph crosses the y-intercept in any case. Let me give you an example. If, for example, we are to draw the graph of y equals x plus 3. You can see that in this graph, the value of a, or your m, the gradient, is equal to 1. There's an invisible 1 in front of your x. And the value of q is equals to plus 3. What this means is my graph have shifted 3 units upwards. Using the intercept method, I'm going to draw the graph of y equals to x plus 3. So intercept method meaning x-intercept, the value of y, that is where the graph crosses the x-axis, the value of y is 0. So using the equation y equals x plus 3, I'm going to have y is 0 equals x plus 3, therefore the value of x equals to negative 3. So my point, or the coordinate for my x-intercept, will be negative 3 and 0. Doing the same for my y-intercept. At y-intercept, the value of x is 0. So therefore, my y, using the same equation, my y equals x is 0, so I have 0 plus 3, so therefore y equals to 3. So the coordinates will be x is 0 and y is 3. So drawing the graph of y equals x plus 3, I have, because I know that the value of a, or my gradient, is positive 1, it's going to be a positive gradient. And then looking for the two intercepts, I have negative 3 and 0. So if x is negative 3, y will be 0. So I have the point shown. And the second intercept I have, that is 0 and 3. So I have if x is 0, y is 3. So drawing the graph, I'm going to have a straight line as shown. And I'm going to label my graph. That's the graph of y equals x plus 3. So that is all about the linear function. The next function we will look at is your quadratic function or your parabola. For your quadratic function or the parabola, I'm going to start with the standard equation, which is your y equals ax squared plus q. And like your linear function, I'm going to start with the value of a. The value of a determines the shape of the graph, while the value of q determines the vertical shift. So similar to your linear function, if your value of q is greater than 0 or the value of q is positive, then we have the graph shifting vertically upwards by q unit. And if the value of q is less than 0, we have a downward shift by q unit. Going back to the value of a, we said a determines the shape of the graph. So if I have the value of a greater than 0, or it's a positive value, we have a concave up or a smiley face. So our graph is going to have a smiley face, or what we call concave up. And if I have a less than 0 or a negative number, we're going to have the graph concave down or a sad face. A is also referred to in some textbook as the vertical stretch factor. The value of a, if we have a bigger value for a, then we have the arms of a parabola closer to the y-axis. So the value of a determines the shape of the graph and also determine if the graph is going to be the arms of the graph closer to the y-axis or further away from the y-axis. Also note that if I have my graph, if it's a smiley face or the value of a is greater than 0, then we are going to have a minimum value at a turning point. And if we have the value of a less than 0, that's concave down, then we're going to have a maximum value at the turning point. Also, if you want to talk about the domain and range for a parabola, the domain is your x values, and x is an element of real numbers. The range is being determined by the shape of the graph. If we have a minimum, then we have the y value for the range will be greater or equal to the minimum. That's q. Likewise, if you have a maximum, then your y for your range will be less or equal to your maximum, which is also the value of q. So what it means in summary is if I have a minimum, the q value determines whether my range is going to be greater or equal to that value or less or equal to the value, depending on if it's a minimum or a maximum. Let's look at drawing a parabola. If we are to draw a parabola, the few things you need to take note of are 1, the shape of your parabola. That means the a values determines the shape of your parabola if it's going to be concave down or concave up. The second thing you need to determine is your y-intercept. Y-intercept is where the graph is passing through the y-axis, and at that point, the value of x is equal to 0. Also, you need to consider your x-intercept. And at x-intercept, where the graph passes through your x-axis, the value of y is equal to 0. Also, you need to determine your turning point. Your turning point usually coincides with your axis of symmetry. Let's look at an example. If we are to draw the quadratic function y equals x squared minus 4, going through the steps stated for drawing a parabola, I start with the shape. You can see that the coefficient of x squared is 1. There's an invisible 1 as shown, such that the value of a, which is 1, that's greater than 0. So what that means is my parabola will be concave up, or a smiley face. The next calculation I'm going to run through are my y-intercept and my x-intercept. Starting with my y-intercept, for y-intercept, the value of x is equal to 0. So I'm going to be using the equation of the parabola to calculate what the coordinates of my y-intercept is. So I have y equals x squared minus 4, x is 0, so I'm going to replace my x with 0. So I have 0 squared minus 4, that's equal to 0 minus 4. So therefore y equals to minus 4 or negative 4. So the coordinates of my y-intercept will be x is 0 and y is negative 4. Then I move to I've done my shape, I've done my y-intercept. The next step is my x-intercept. So x-intercept, the value of y equals to 0. So using the same formula, I have y will be 0 equals x squared minus 4. Moving my negative 4 to the other side, I have x squared equals to 4. And to find the value of x, I'm going to square both sides. So therefore, my x will be plus or minus 2. So the coordinate of my x-intercept will be, I have, if x is positive 2, y will be 0, or if x is negative 2, y is also equal to 0. So I have the parabola passing through the x-intercept at 2 points. Also note that for my turning point, that's the last point, I'm going to call that my TP. For my turning point has Q equal to my Y. So, and you can see from my question that my parabola has shifted 4 units downwards because it's negative 4. It hasn't shifted to the left or to the right. So therefore, the value of my Y is Q and my X will be equal to 0. So what that means is the coordinates of my turning points will be X is 0 and Y is Q, which is negative 4. So the points I need at this point in time are my y-intercept. I need my x-intercept, the 2 points, and then the coordinates of my turning point. So drawing my parabola, I have my x and y-axis as shown. Then you can see that my y-intercept is also my turning point. So I start with that. My turning point will be 0 and negative 4. So that's 0 and negative 4. Then my x-intercept, I start with plus 2 and 0. I have that as plus 2 on my positive x-axis. And my negative 2 and 0. And drawing my parabola, passing through all the points shown. It's not drawn to scale. It's just a rough sketch. So labeling all the points shown, I have 0, negative 4. I have that point as 2, 0. I have the intercept negative 2, 0. Then I have my parabola well tagged. That's y equals x squared minus 4. So you can see that the value of a is greater than 0, and then I have a smiley face for my parabola. If I'm to determine the domain and range, for my domain, my x is an element of real numbers. But for my range, I have a minimum. So therefore, my y will be greater or equal to -4. Note that my minimum is at -4 as shown. Let's look at the next function, which is our hyperbolic function. For our hyperbolic function, or the hyperbola, for grade 10, we have a standard equation to be y equals a over x plus q. I'm going to start with q. Like we explained in the previous functions, the value of q determines if there's going to be a vertical shift upwards or downwards. So if q is greater than 0, it's positive, then we have an upward shift. And if the value of q is negative or less than 0, then we have a downward shift. Going to the value of a, like we explained in a parabola, the value of a determines where or which quadrant a graph will be located. So if we have a positive value, or if a is greater than 0, a graph is going to be located in the first and the third quadrant. But if the value of a is less than 0, then a graph is going to be located in the second and the fourth quadrant. For our hyperbolic function, we have two asymptotes. Let's start with the vertical asymptote. For a vertical asymptote, the value of x is 0. That's for grade 10. But for our horizontal asymptote, we have y equals to the value of a q. So what that means is we can have a 0 as a denominator, and then we can have a value of y equals to q, because a over x cannot be 0. So if we are to draw an hyperbola or a hyperbola, we have, starting with the value of a, we have a value, which will determine which quadrant a hyperbolic function is going to be located. Then we go to our y-intercept. Y-intercept, the value of x will be 0. Then we have our x-intercept, where the value of y equals to 0. Then we have our asymptotes, the vertical and the horizontal asymptotes. Let's look at an example. If you had to find or draw y equals 2 over x plus 1, I'm going to start with my vertical asymptotes, because the value of x cannot be 0. We'll start with the vertical asymptotes. We have x equals to 0. Then we move to our horizontal asymptotes, where the value of y will be equal to a q, and q in this case is equal to positive 1. Then we have y-intercept. Because we can't have x to be equal to 0, then we don't have a y-intercept. But we have an x-intercept, so at x-intercept, the value of y equals to 0. If I put that back into the equation, I have 0 equals 2 over x plus 1. I have 2 over x equals to -1. So therefore, the value of x, if you solve that, will be equal to -2. So the points will be, or the coordinates of that x-intercept will be -2 and y is 0. I'm going to pick a couple of more points on the graph. If I have, for example, x equals to -1, I just need a couple of more points to draw a good graph or close to perfect graph. So if I have x is -1, I'm just picking a couple of random points on the graph. I have the value of y equal to -1. Note that I'm still using the same equation, y equals 2 over x plus 1. Then if I have x is 2, I have y equals to +2. That's 1 plus 1. One more point, if I have x equals to +1, then I have y equals to 3. So drawing a graph, when drawing your hyperbolic function graph, the first step is to draw your asymptotes. We have a horizontal asymptotes at y equals to q, which is +1. The asymptotes are points on the graph that the graph is not going to touch. And then we have the vertical on x equals to 0, so that's exactly on our y-axis. The next point is to look for the given point. I start with my x-intercept. X-intercept, that's -2 and 0. So I have -2 and 0. -2 and 0, so it's going to be on that line. Then the points I calculated, I got for -1, the value of y is also -1, so I'm going to look for one more point there. -1 and 1. So if I draw my graph at that point, it's going to pass through the given point. Note that my graph doesn't touch my asymptote. Then remember, the value of a in this graph is +2. So I have my graph in my first quadrant and my third quadrant. So I'm going to use the points I calculated earlier to pick the other points in the first quadrant. So if I have +2, y will be +2. So I have that point as shown. And the last point I'll be using is if I have x is 1, y is 3. So I have another point as shown. So my graph is going to go through the 2 point. It's just a sketch. I'm going to draw it again. And note that the graph doesn't touch your asymptote. So that's the graph of labeling my graph. I have y equals 2 over x plus 1. Then I have the 2 point, 1 and 3. And I have the second point, 2 and 2. I have -2 and 0. And then I have -1, -1. And I have always label your asymptote. I have y equals +1. So going to the last but not the least function, that will be my exponential function. For my fourth but not the least function, exponential function, the equation will be y equals a times b to the power of x plus q. The value of q remains the same. That's my vertical shift. Vertical shift. And if q is greater than 0 or positive, that's going to be a vertical shift upwards. And if the value of q is negative or less than 0, that will be a downward shift. In this case, the value of b determines the shape and steepness of my graph. What I mean is, if I have the value of b greater than 1, then I'm going to have an increasing function. So my graph is going to be in this direction. And if I have b greater than 0, but less than 1, then I'm going to have a decreasing function or exponential decay. So I'm going to have my graph in that direction, and that will be decreasing. For my exponential function, I have my horizontal asymptotes, and for my horizontal asymptotes, I have that as y equals to the value of my q. With this information, if I'm to draw an exponential graph, I need to determine the shape or the steepness of the graph by the value of b. Also, I'm going to find my x and my y intercept like I did for my previous functions. So if I'm to draw the graph of, for example, y equals 1/4, that's the value of b, to the power of x minus 2. You can see that minus 2, which is the value of q, what that means is my graph has shifted vertically 2 units downwards. So starting with my y-intercept, the value of x will be 0. So I have y equals 2 in bracket 1/4 to the power of 0 minus 2. That will be 2 times 1, 2. 2 minus 2, I'm going to have 0. So my coordinate for my x or my y-intercept will be x is 0 and y is 0. Then I calculate my x-intercept, where the value of y is equal to 0. So I have 0 equals 2 in bracket 1/4 to the power of x minus 2. If I simplify, I'm going to have 2 equals 2 in bracket 1/4 to the power of x. I have 1 dividing both sides by 2 equals, then I'm going to apply the exponential law. That will be 4 negative x. So I have 4, 0, that's 1, equals to 4 negative x, and because the bases are the same, x is going to be equal to 0. So I have my x and y intercept having the same coordinates, 0, 0. Drawing my graph. So I'm going to do a rough sketch of my graph as my Cartesian plane. I have my x and y intercept at 0, so I'm going to mark that part. And then I'm going to pick a couple of more points on the graph since I only have my origin as my intercept. So if I pick, for example, if I have x is 1, so if my x is 1, I'm going to put x is 1 in the equation. I'm going to get a corresponding value for y, which is negative 1.5. Or if I pick x is negative 1, not that, I'm just picking random values on the graph, I'm going to have y equals to positive 6. So I'm looking for these 2 points on my graph. I have x is 1, y is negative 1.5. I'm going to have that here. And then I have my x is negative 1, y is positive 6. Before I draw my graph, like I did for my hyperbola, it's important to first of all draw your asymptote. Note that my asymptote is my q value. So I have my asymptotes or my horizontal asymptotes. I'm going to write them down here. Horizontal asymptotes, the value of y equals to my q value, and my q is negative 2. So I'm going to mark that on my graph. And what that means is when I'm drawing my graph is not going to touch or go through my asymptote as shown. I'm going to label that quickly. I have that as y equals to -2. So drawing my graph now, I have a rough sketch. I'm going to label all my points quickly. I have -1 and 6. Then I have the other point that's at 0, 0. That's my x and y intercept. Then I have 1 and -1.5. And this is a graph of exponential graph of y equals 2, 1/4 x minus 2. Thanks for watching. Bye.